Alright, you guys, think way back to when we were solving sine equations. The plan was to get the sine theta alone, and at that point you could figure out which angles have the sines that you found. There could be 0, 1, 2, 3, 4, or a bunch of different answers for these equations. It's going to be the same plan with cosines, except when we get it down to cos theta equals some value, we'll figure out what angle has that cosine. So like in example 1, the best thing that we can do is to factor out a GCF. Out of radical 2 cos squared and cos, the biggest thing we can take out is a cosine theta. If you take a cosine theta out of each piece, you're left with radical 2 cosine of theta minus cosine divided by cosine is 1. At this point, remember how we set each piece equal to 0? And solve. This side is solved for 0. Cos theta equals 0. This side we can add 1 and divide by radical 2. And we see that cos theta equals 1 over radical 2, or rationalize radical 2 over 2. Now both of these values, radical 2 over 2 and 0, are cosines that we already know. If you think about the cosine curve that looks like handlebars, it starts up here, goes down, and then peaks up high at the end. We're looking for where this is 0. This curve is at 0, or on the x-axis, in two spots, at 90 and 270. So there's two places where cos theta equals 0, and that's at 90 degrees and 270 degrees. This one, cosine of theta is radical 2 over 2, is 45 degrees. Now there's one catch. Like with sine, this would have given you two answers. It's the same thing here. There's two places in these quadrants where cosine is positive. According to all students take calculus, cosine is positive in quadrant 1, of course, but also quadrant 4. So this is the 45-degree reference angle that's in quadrant 1, which is 45. In quadrant 4, 360 minus 45, or 315. So this half of the equation gives you two answers as well, 45 degrees and 315 degrees. These are the four answers that we were looking for. And if you also look at the graph, I've graphed this strange cosine function for you. If you look at this thing and you're looking for zeros, you can see that there's one right there, halfway between 0 and 90, which would make it 45. One right on 90, one right on 270, and then one halfway between 270 and 360, which would be 315. So these four answers should kind of make sense to you. Pause the video and try number 1. You guys know enough trig by now that some things should appear to you as big red flags when you see sine subtraction, or cos addition, or sine of the half angle, or cos of the double angle. Automatically, these things should point you to your reference sheet because you can't use these things as they are. Today, we're going to see these mixed in with equations. We're going to see sine of the double angle, cos of the double angle, and tan of the double angle. You can't use these as they are. Each and every time, you have to replace them.
People of the internet, this is the best day! I'm not in a party. I am a party. Everywhere I go is a party. People get their brains ready because I'm going to tell you something. If it doesn't make the world better, don't do it. Quit posting on your Facebook and listen to me. Big announcement, everybody! You know, I'm just a kid with some videos. Rain Wilson. Apparently he's famous, but I never heard of him. But he invited me to be a guest star on this channel.
Like here in example 2, we have 3 cos 2x plus sine x minus 1 equals 0. This cos 2x automatically should jump out at you. You can't use this double angle. We need to replace this double angle with something that it's equal to. If you look at your reference sheet, you notice that there's 3 things that you could possibly replace cosine of 2a with. One has cosine and sine in it. The next one has only cosine, and the last one has only sine. If you look back at the equation we're dealing with, we have sine in ours. What that means is that if you can pick one that also is in terms of sine, then you're going to have an equation that's all in terms of sine. If you pick one that has cosine in it, you're still going to be stuck because you'll have an equation with cosine and sine. So let's pick the one that has only sine in it, this last one, 1 minus 2 sine squared a. We're replacing now this cosine of 2x with something that it's equal to. On the reference sheet, we just said that that was 1 minus 2 sine squared x. Once we distribute this 3 and rearrange some things, this is going to be a normal sine equation. If we distribute that 3 to each piece, we're left with 3 minus 6 sine squared x plus sine x minus 1 equals 0. I'm going to go ahead and add everything over to that right-hand side. So we are left with 6 sine squared minus sine minus 2. Let's factor this thing. 2 things that multiply to 6 sine squared, we could use 6 sine and sine, or 3 sine and 2 sine. That's why I'm going to start with this 2, because there's only one option for 2. These 2 values have to be 2 and 1, so let's fix those. The numbers that I want to use for 6 sine squared are 3 sine and 2 sine, because if we match up 2 sine with 2 and 3 sine with 1, we can end up with 3 sine and 4 sine, which could definitely make negative 1 if the 4 is negative and the 3 is positive. At this point, we know what to do. Each of these gets set equal to 0. So 3 sine minus 2 equals 0, and 2 sine plus 1 equals 0. Solving each of these for sine x, we see that sine is 2/3 and sine is negative 1/2. You guys know that this 2/3 is going to give you 2 answers because it's a positive number. And we know 2 places where sine is positive. According to all students take calculus, sine is positive in quadrants 1 and 2. This one, this negative sine, is also going to give you 2 answers, but sine is negative in quadrants 3 and 4. Let's do the 1/2 first, because I know which reference angle that is. The angle that has a sine of 1/2 is 30 degrees. That means it's the 30-degree angle down here in quadrant 3, or 180 plus 30, and the 30-degree angle down here in quadrant 4, or 360 minus 30. This 2/3 is not an angle that we memorize, so we can use our calculator. Which angle has a sine of 2/3? We can type second sine of 2/3 to find which angle has this sine. If your calculator is in degrees, you'll see that about 42 is the angle that has this sine. In quadrant 1, that's easy. This is just 42 degrees. In quadrant 2, this is 180 minus 42, or 138. This says we should be looking for 4 answers, and we found them. 42, 138, 210, and 330. Pause the video and try number 2 below.
I said, Ray Wilson, I bet you want the internet better, but if you want me, you have to get some pancakes. I'm only gonna do it if I get pancakes. Who names their kid Rain? Rain. Still waiting on the pancakes. Raining in the sky, it's raining in the sky. Rain Williams, Rain Williams. It looks like I'm gonna be doing it. Alright, pancake people, the internet needs to look out. Oh, pancake. Can't wait.
So pancake, subscribe.